All right, let's pull back the curtain on something that pretty much powers our entire digital world: databases. We're going to dive into what they are, why they matter, and get to know the absolute king of the open source world, MySQL. I mean, really think about it for a second. That shopping cart you left items in last week, it's still there. Your social media feed that just never ends. Or, your bank balance. How does all that information just exist? How is it all stored, managed, and pulled up in less than a second? Well, it's not magic, that's for sure. Huge companies like Facebook and Google, they're all built on this incredibly powerful, super structured foundation. And the heart of that foundation? It's the database. Now, to really appreciate why databases are so revolutionary, we have to take a quick trip back in time. Back to let's call them the digital dark ages of storing information. Before we had these modern databases, all our information was basically just kept in separate, simple files. Think of basic text files or a bunch of different spreadsheets. It was like trying to run a library where all the books are just loose stacks of paper, with no index, no system, just total chaos waiting to happen. So the first huge headache this caused was data duplication. You'd have the same customer's address stored in a sales file, and also in a shipping file, and probably in a marketing file too. It was just wildly inefficient, a total waste of space that created so much digital clutter. And that duplication led to an even bigger, more frustrating problem. Let's say that customer moves. Okay, so you update their address in the shipping file, but what if you forget the sales file? Now you have two different conflicting addresses for the exact same person. Which one's right? This is data inconsistency, and it was an absolute nightmare for developers. So yeah, this system just wasn't going to work long term. We clearly needed a better way. And as you can see here, we started to evolve. We went from those simple files in the 60s to some early database systems in the 70s. But the real game changer, the big one, that arrived in the 1980s. The Relational Database Management System, or RDBMS, and it changed everything. And look, this wasn't just a small improvement. This was a whole new way of thinking about data. It was a complete shift that brought logic, order, and most importantly, reliability to all that chaos. The hero of our story is a computer scientist named Dr. E.F. Codd, and he proposed this idea that was, well, it was beautifully simple, but incredibly powerful. He said, let's organize all data into simple tables, kind of like spreadsheets. And then, and this is the genius part, let's create relationships between them. And just like that, no more disconnected, messy files. So here's how it works. In this relational model, you might have one table for all your customers and a totally separate table for all their orders. Now, instead of copying the customer's full address into every single order, you just give each customer a unique ID, a special key. Then, in the orders table, you just reference that customer's key. So if you need to update an address, you change it in one spot, and it's instantly correct everywhere else. Simple, elegant, and so powerful. This new model also came with this really powerful guarantee. You see, relational databases follow 4 sacred rules, known together as the ACID properties. And these aren't just suggestions. They are the absolute bedrock that makes these databases trustworthy enough for our most important information, like our money. Let's make this super clear with a bank transfer. First, atomicity. This means that the whole transaction is an all-or-nothing deal. You can't take money from one account without putting it in the other. It either all happens or none of it happens. Next, isolation. This means that while your transfer is happening, no other transaction can jump in and mess with it. And finally, durability. This means once the transfer is done and saved, it stays saved even if the whole system crashes a second later. In short, ACID means your data is safe, period. Okay, so we have this amazing relational model. But which technology actually took that idea and ran with it to power the entire internet? Well, it's time to meet our main character, MySQL. So, MySQL was born in 1995, and it jumped into a world filled with super expensive, proprietary databases. But by being open source, it wasn't just free to use, it was a revolution. It put the power of a serious database into everyone's hands, and it quickly became the backbone of the booming internet. Its journey eventually saw it acquired by Sun Microsystems, and then later by the database giant Oracle, which really cemented its place in the corporate world. And its dominance today, well, it's just undeniable. I mean, look at these numbers. With over 42% of the market share, MySQL isn't just one of the players. For a huge part of the web, it is the game.
It's the engine behind millions of websites and apps, from tiny little blogs all the way up to massive platforms.
So, what's the secret? Why do so many developers love it? Well, first, it's open source, which means it's free. That's a huge deal. Second, it runs on pretty much any operating system you can think of. And finally, its learning curve is way friendlier than some of those giant, super complex enterprise systems. It puts some serious power within everyone's reach. Okay, so we know why it's so popular. Now, let's pop the hood for a second and take a quick look at how it actually keeps all that data organized. At its core, you've got a few key pieces. There are tables, which of course is where the data actually lives, all neat and tidy in rows and columns. Then you have indexes. These work exactly like the index at the back of a book. They create a shortcut so the database can find what it's looking for super fast without having to read every single row. And then you have triggers, which are pretty cool. They're little automated actions that fire off whenever data changes, like automatically sending a confirmation email right after you make a purchase. Now, one of the most flexible things about MySQL is that it supports different storage engines. You can think of these as specialized filing systems for your data. The default is called InnoDB, and it's an absolute powerhouse. It's fully ACD compliant, which makes it perfect for things like e-commerce, where every single transaction has to be perfect. But if you're running, say, a blog that's mostly just being read, you might choose MyISAM instead, because it's optimized for blazing fast read speeds. It's all about picking the right tool for the job. So, we've covered the history, we've looked at the technology, and we've met the champion. But what does any of this mean for you? You know, understanding MySQL and the language that controls it, SQL, isn't just some abstract tech skill. It is a passport to some of the most in-demand jobs in the world. Whether you want to be a developer building apps, a database administrator managing massive systems, or a data engineer building the pipelines for modern AI, these skills are absolutely fundamental. Think about it. Every single click, every post, every purchase, it's all data that has to be stored, managed, and protected. The systems that do all this are the real foundation of our digital lives. So the only question left is, are you ready to be one of the people who builds it? Thanks for watching.